Yeah.
When you start, you could hit the record key, please.
So
Whenever you're
it's
starting.
no, it
One
already
second.
shows me that it is recording. So I'll. All right. Hey everyone. Welcome back. This is again. This is the fourth session that we are having on Android application security training, and I welcome you all again. So, as just a small recap from what we did yesterday. So we looked at a couple of things like insecure logging, and we also looked at a couple of things such as uh, you know uh, input validation based issues and all of them. So today we'll be looking at a couple of other furthermore things, from considering the Diva application and also considering the certificate files. Okay, so not just that, we'll be doing a small recap on what we have done so far in this whole week, because the sessions from the next week are going to be a bit more complex, and I want you all to know the fundamentals and basics what we have done so far, so that it becomes a lot more easier for you guys. Okay, so let's get started with today. So if you guys could remember from the previous sessions that we were able to extract the reverse engineer the Android application and extract bunch of things from it, right? So if you remember, let's say if this is the Diva applications folder that we were able to reverse, when we go into the original folder, we saw something called Android manifest.xml file, that kind of gives us all the details that is needed for us. And also we also looked at something called as meta-inf folder, which gave us things such as the certificate files and all of them. We're basically three different sort of files that we, if we remember. uh, Let me just open something. Okay, so in the original here we have a meta-inf folder. So these are the main files, if we could remember. As we all know, these two files have the same content. This is an RSA encrypted certificate file, right? So what we are going to be learning today is more on how, from an attacker's perspective, it is easily possible, for the attacker to manipulate the certificate file and sort of bring in his own certificate file onto the application. Okay, so if you could remember yesterday, while we were looking at the certificate file, I was mentioning that these are self-signed certificates. There is no authority that is going to give an application a certificate, and every single application developer can create his own certificate and attach to the application. Okay, so things to remember from the previous sessions is that the cert.rsa, this is a X509 version 3 certificate. So X509 is a name that is given to these kind of certificates. It's the naming conventions for these kind of certificates is totally different. Okay, so the information in it is structured by the key tool in the following way. We have things like the owner name, the owner of the public key, organization associated to that individual, then issuer, declares the issuer of the X509 version 3 certificate to the holder. Okay, so usually it remains the same person who has issued it, the owner and the issuer. And the serial number and this is an identifier, a unique identifier for the certificate that is issued. And the valid from and until kind of tells us when what is the expiry date of that particular certificate. Okay, the certificate fingerprints is nothing but a digest sum of the certificate. It is basically used to make sure that the certificate has not been tampered with. So this is kind of very important, for the application to check back with the Play Store, to check if the application has been tampered or no, or something as such. Okay, so as again I had mentioned, remember that in this scenario there is nothing called a certificate authority. Okay, so all the certificates are self-signed. Okay, so let's get started here. So if we remember, we had our diva-beta.abk, right? So what we are going to be doing today is, let me open up the presentation. Okay, so let's start the presentation. Okay, so this we already know. Okay, so the steps. So what we are going to be doing at this point of time is the resigning of the certificate. Okay, the resigning of the application. Okay, so why we do it, let's also look into that. So let me write down resigning the application as the topic. Okay, so the reason why we do it, why an attacker would do it, what uh, the main reason would be to implement a malicious code into the application and then resign the application so that the devices could be able to install them. Okay, so let's say if I take up a Twitter application or a Google application and I reverse engineer it, add a malicious code into it, and then again repackage it and re-sign it and sort of give it to any of my victim, and he'll be able to install it on his phone, then then that kind of causes an issue, wherein the attacker would be, I mean, it won't cause an issue on the operating system, but it would basically sort of there is a malicious application that is running inside the phone, which is kind of sending me all the necessary details that I want. Okay, be it your gallery, based on the permissions again, be it your gallery, your contact, and bunch of other details. Okay, so let's actually look into this now. So we have the diva-beta or APK. What I'm going to do is open up the terminal. Okay, so in the terminal, if we remember, right now I'm in. Okay, let's get into the desktop. So we are going to be using this tool called as jar signer. Okay, so jar signer is basically used to verify and sign the applications with a certificate. Okay, the signatures of the certificate. Okay, so what we are going to do is we are going to use this command called -verify -verbose, and we are going to give the name of the APK file. So once we give that, it's going to do a look into the certificate file and says, signed by such and such guy. See an Android debug digest algorithm is SHA1, signature algorithm SHA1 with RSA 48-bit key, and all of this. Okay, so we could sort of ignore the warnings at this point of time. They don't really matter much for us. Okay, so it says the jar has been verified. Okay, the jar is verified. Okay, let's remember this point here. Okay, so what next we are going to do is let's look into what our presentation has to say. Okay, how do we remove the certificate and the signature? So the steps for removing is fairly simple. We need to unzip the APK file, remove the meta-inf directory, and now we would be able to sign the application. It's fairly simple as this. Okay, so what we are going to do is let's unpack this. Since we have already unpacked it here, let me move this to trash. uh, this up. I'm going to clear this. I'm going to use basic APK tool space -d space diva -beta.apk. So okay, I need to just use D here. Okay, so since this got decompiled here, we have diva-beta. Okay, so what I'm gonna do is for now, let me put it into this folder called as test. Let me remove this whatever is there in this test folder. Okay, so I'm just gonna push it here. Okay, so let me get into this, into the original. So this meta-inf folder has these three files. I'm gonna delete this. Let's go back, and now I'm gonna compress this. Okay, so we have a zip file now. What we got to do is we got to rename this from .zip to .apk. I'm gonna say use apk file. Okay, so now we have an apk file which is unsigned, but when you try to install this unsigned apk into a device, then it would sort of create some sort of an issue saying, hey, your apk is not signed by any developer, so I'm not going to install it on my device. Okay, but so for that we got to ensure that this apk is signed somehow. So for this we are going to be using two major tools. Okay, so I really hope you guys are not getting confused at this point of time. Anyways, while doing a recap of what we have done so far, we could again be able to sort of go through these steps. Okay, so the resigning the application. Okay, so we have how we do it is we use this tool called as key tool. Okay, so there is this command line that we are going to use using the key tool. First thing that we need to do is we need to set up a key store. Okay, so what is a key store? Key store is pretty much like a list that will have all your private keys, okay, that is needed to sign an application. Okay, so the more on private key, public key, the encryption side of it in the upcoming sessions we'll take up. Okay, but for now, just remember that we need to set up a key store. Key store is a place where you will have all your keys that are present. Okay, so let's sort of I've already written down this particular command here. Okay, it's not there, I guess. Let me go back to this and take in the command. So I'm going to just paste this here. So name of the key store, let's give some name like is key. Okay, then you give an alias to your uh, key, the alias to your key. So if you want your keys name to be cert.rsa, we give it as cert. Okay, else we could give something else. Okay, so for now, to be on the safer side, let's just give cert. Okay, the validity here could be up to 10,000 days. Let's for now just keep it to 1,000 days. Okay, so this is our okay, let me correct this, it's validity. Okay, so this is our command line for key tool. Okay, so we are basically saying, hey key tool, generate a key with minus verbose, with a key store with the name of the key store here, with an alias for the key, and with the key algorithm to be RSA, and the key size to be 2048 bits, and the validity for 1,000 days. Okay, so this is what we are basically saying here. What we are going to do is we're going to just copy this part. Okay, and let's go to the terminal. So let me clear the terminal and increase the font size here for you guys to see. I'm just going to paste this here, click enter. Let's give a password for the key store. What is your first name and all that? Let me okay, so it says that okay, so our key store has been stored now with our private key. So let me do an ls, let me clear the screen first. Let me do a list. So I have my nick key st here present here. Okay, so what I'm gonna do now is just for our just to make things easier for us, I'm gonna push this to the test folder as well. So okay, so both the files are right here, the unsigned APK and the key store. So to sign this application, we're going to use this tool called as jar signer. Okay, so once the password is set up for the key store, the key tool uh, will prompt for the information that will be used to build the certificate, which we did. Now you would see a private and public key and also a self-signed certificate stored safely encrypted. Yes, we see that. Then use this key store to sign the application. Okay, since our key store is created, which means the private key is created, now we need to use that private key and sign the application. Okay, so I'm just going to copy this part. I know there would be some confusions with you guys at this point of time. We'll take all the questions, once we are done with this. Okay, so let me open up the Sublime editor. Okay, so we have jar signer hyphen verbose hyphen signature algorithm, which is MD5 with RSA. So though MD5 is a weak algorithm, let's go ahead and use it. That's fine. Uh, Digest algorithm is SHA1. We can again use this. There's no problem. Okay. So name of our key store. Okay. So let's name, what is the name of our key store? It is NIKYST. Okay. My APK file name is diva-beta.apk and the key alias is cert. Okay, so I'm just gonna copy this part. Okay, so there is a small issue. Okay, this is done. So I'm just gonna copy this and open up my terminal. Okay, so let me paste it here. It says enter the passphrase. Remember we gave a password, right? Okay, so it is throwing up an error. Okay, so I think it is searching for the key store right here. So let me put it back right here. Okay, so hence it kind of threw up an error. Okay, so let me do this again. Okay, able to sign jar. Okay, there's some problem with this. That's fine. Invalid entry compression size expected, but okay. Okay, I think there is some problem with the jar signer itself at this point of time. No worries, I'll fix this up. But till then, I think we could go on with the rest of the other things that we are supposed to do. It's okay, but I'll make sure I'll get it back up and running. So we'll go with the next thing that we are supposed to do, which is the diva. Okay, so let's look into the bunch of other things that we were looking at the diva part. So our next vulnerability that we'll be looking is the access control issues. Part one, which allows, the objective is basically you are able to access the API credentials when you click the button. Now try to access these API credentials from outside the application. Okay, so the hint that they've given us is components of an application can be accessed from other apps or users if they are not properly protected. Components such as activity services, content providers are prone to this. So the hint that they give us here is that components such as activities, so these application components, if they are not correctly protected, then it may sort of lead to some issues. So if I click on this view API credentials, it kind of gives me details like API key, what is the API key, what is the API username, and what is the API password. Okay, so our goal at this point of time is, though we are able to access these by clicking this button here, we need to be able to access these this thing without clicking this button or without even entering this application. Okay, so what we are basically going to do is, since they have told us that components such as activities, services, content providers are prone to not being properly protected, which means that we got to look into these places where we get to know more about these activities. So if you could remember, the places where we could be able to we could get to know more about these kind of files is the Android manifest.xml file. So what I'm going to do is I'm going to open this up with Sublime Text Editor. Okay, so if you just look at the place where this particular activity is stored, I think for that let's also open up the JD GUI. Okay, so let me put this up right here. So for now, the one that we are using, the access control issue 1. Okay, it says jacker.asim.view creds. So this is the intent that they're using. Okay, so as I had explained before, that every single screen on your mobile application uh, is an activity. Okay, so if I'm seeing this particular screen, so this is an activity. Okay, or if I'm seeing this screen, this also is an activity. So what we are going to be doing here is look at the activity that is specific to this access control issues. If we look at the JDGUI, okay, so here under the access control one activity dot class, we see that there is an intent that they have used. Okay, so we need to look at this area specifically, the intent that they have used. So what is an intent exactly is the next question that would come to your mind, right? Okay, so this is the intent. Okay, so intent is something that would basically allow any other application to sort of use a portion of your application if you allow it. So let me put it in a better way. Okay, so for example, here if we see, this is the activity, right? uh, where the Android name is jacker.asim.diva, so diva.api creds activity. Under that, they have this intent filter. Okay, so they're trying to protect this particular action using an intent filter for this particular activity. So when they use an intent filter, what it allows is another application to access the resource of your application. Okay, so in this case, since they have used the intent filter, okay, so any other application or any other user, if your phone is rooted, uh, you know uh, would be able to access this particular activity. Okay, so we know that the intent here would be jacker.asim.diva.action.viewcreds. Okay, so what we are going to be using is an activity manager here. Okay, so I've already written down the command, so that to just to make it easier for you guys. So this is the normal ADB shell that we are using, and we are going to be using the activity manager. So activity manager is basically that helps to sort of invoke any activities or anything as such in the mobile device. Okay, so we are going to say am space start, which would start this particular activity, and the action that is part of the intent filter. Okay, so let me close this application for now. Okay, to be on the just to so that we are able to understand it much better. I'm just going to take this and open up the terminal. So when I click on this, so it's going to load up that particular activity that was using intent filters. Okay. So what we need to understand here is never to use intent filters for any activities that are very critical. Something that would sort of store your credentials, or something that is very something like your login uh, uh, activity or something as such. Because when you use an intent filter, that would export that particular activity, and when that particular activity or the application component is exported, when I say exported, it means that any other application on the device would be able to easily access that particular resource of your application. Okay. So that was about the intent filters and the trying to sort of use the flawed access control to get the data. Okay. So any questions that you guys have from previous sessions or this session, we could take it up at this point, because I remember yesterday we had a lot of questions, and I totally like missed to see the questions yesterday. And once the session was over, I was able to look at the questions and then realized I completely missed that part. So today I'm totally available to take any questions on so far whatever we have done for this whole week, and I'll be just doing a small recap on what all we have done so far. Go ahead, guys. All right. I think it would be a lot more easier thing, to go with the things that we have done so far. Okay, someone's already asked a question. Can we get proper installation procedure steps to practice? Yes, we'll be doing that. Over the weekend, I will be sharing all the files and all the installation details, procedures, and all that on the Google Drive, and that will be delivered to you guys. From there on, you guys would could be able to sort of get started with it. Also on Monday, we will be focusing completely on the setting up the pen testing environment, for all of us, right from the scratch, because I know things like installing APK tool, or be it installing the JDGUI and all that. How do we do it, and all of that is a big question at this point of time. Yes, we will be able to do it. I know we'll be taking that up on Monday. Okay, so Monday is a complete session that is specifically meant for us to sort of go ahead and install things. Okay, so how does these tools work on Windows? So one thing is that these tools are pretty much standalone. Couple of them are written in Python and couple of them are written in Java. So if you have Java installed on your system and if you have Python installed on your system, these tools would work without any sort of a hiccup. Okay, that's for sure. So they're not like dependent on which operating system that you're running or something. So all these tools are completely available for Mac, Linux, and Windows as well. So nothing to worry from that point. Okay, so okay, someone is asking, I've installed Tamer and you're practicing it. Okay, Android Tamer is a pretty good a Linux distro that we can use. Okay, so it's a really good one. It comes with a lot of pen testing tools that we want. It's pretty much like Kali Linux. Android Tamer is, again, it's created by a homegrown hacker called Anand Srivastava. It's an amazing distro. I would suggest someone who is really interested in getting into mobile security space to use that distro. It's again open source and freely available. The only problem with that is it's a pretty big file. It comes up to around 5 GB of so the downloading that big file itself is a big issue. So henceforth, what I did was I've sort of only selected the applications that we'll be needing at this point of time, and I've sort of given it to you guys to install it. And I mean, I'll be giving it to you guys to install it. Okay, so we can go ahead and install these distros, so there's no problem with that. All right. Okay, so let's just do a small recap on what all we have done so far. Okay, so day 2. Okay, so the tools. Okay, so we started off with the basic, the Android architecture and all of that, right? So remember, guys, this is very important considering the Android security, the Android architecture. So we have 5 different set of components. We have the application, we have the application framework, the libraries, the Linux kernel, and the Android runtime. Okay, so this is the kernel part, contains all the driver softwares that will help us to connect the software with the hardware components. Okay, so there are different set of libraries that are specific for different functionalities, like SQLite for databases or SSL for security, OpenGL, SGL, and media frameworks for the UI UX part. Okay, then the application frameworks. So these are pretty much like your library files. I mean, not like exactly libraries, but header files in your be it your Java or C++. You have separate set of frameworks for separate set of functionalities. Like if you want to implement calling or SMS features, you're going to be using something like a telephony manager. If you want maps to be implemented, something like if you're creating an application like Uber or Ola or something like that, you're going to be using tools like location manager. Okay, so in the similar lines, you have your application, which gets bundled up with all these different set of things, be it your application frameworks and libraries, to help perform different functionalities. Okay, so finally we have Android runtime, which comes with a couple of core libraries that are specific to Java. Again, other than that, we have something called Dalvik Virtual Machine, which we all know is mainly for running the .dex files. As we all know that every single application on Android device runs in its own, sandboxed environment. Okay, so this is like a very basic Android architecture that is much needed. Let's go back. What else we did? So we looked at how the security is implemented at different levels. We looked at the security at the operating system level, which is at the Linux kernel level. We got to know that every application is given a separate unique username, right? That is one thing. And apart from that, whatever process that gets done, those are numbered or those are referred using that particular username. Okay, then the applications unboxing, we know how it is done using Dalvik virtual machines. Then the secure inter-process communication, we'll be learning it in the next coming week. So we'll be using a tool called as Drozer, mainly to sort of get to see all the different sort of application components and how inter-process communication usually is done. Okay. Then we looked at application signing. That is not yet complete though. Today we had some issues. I'll get that fixed, and we'll make sure by Monday I'll be able to sort of show you guys that. Then permission model. We also got to look at the Android manifest.xml file and look at the different sort of permissions that were there, right? Google bouncers is something that is totally not in our hands. It's something that gets maintained at the Play Store. Okay, so we'll also get into the Google bouncers part after a couple of sessions, but we may not be able to do much with that because we don't really have anything to show how Google bouncers work. Okay, so these were a bunch of exercises that we tried. Okay, so setting up the environment, these are a bunch of tools that we'll be using. Again, that is for Monday, we'll do that. So APK architecture, this is very, very important for us. because when you want to reverse engineer, I know this architecture is most important. So usually the APK is built from the Java code, but nowadays APKs are being done with different cross-platform based applications as well, like be it React Native or Xamarin or Cordova and bunch of other things. So there is a .java file that gets converted to the .class file using the Java C, which is basically a bytecode, the .class file. And all these different sort of bytecodes are then converted to the DEX files using the DX tool. Okay, so this kind of gives us to a Dalvik executable called classes.dex. Okay, so the classes.dex file, the Android manifest.xml, and bunch of other resources together are combined together, and they're given a certificate, and then they are converted into an APK file. Okay, so this is the complete process. What we do as a security engineer, we would be reversing this whole process right from the beginning, from the APK to the .java code. Okay, so that's one part of it. Then what are all the tools that we really used? We used Dex2Jar, we used JDGUI, the APK that we were testing was Diva, then we used the APK tool. Okay, so let's again do how look into how APK tool is used. I'm sure you guys remember this. Um, where am I right now? Okay, let me get into the desktop. So again, I'm sure you guys already know this. APK tool space D space, you write in the name of your APK file. Okay, it kind of it does the reverse engineering and gives you the complete file. Okay, so this is it. This is fairly simple. From there, you also use the dex2jar, which is for this we're going to say d2j hyphen dex2jar space what we give the APK tools APK file. Okay, so it says that it already exists, so we could overwrite this or we could move it to trash. So I'm gonna do it again. Okay, so that is created now. Okay, so using JDGUI, we open this up, right? We open this up using JDGUI, and we get to see all of these. We read the contents of the source code, and then we sort of figure out how things are working, how the functionalities are working. Okay, so that's very basic here. Okay, so once we open up the emulator here. Okay, so the emulator that I'm using is the Genymotion emulator. It is, again, you get the free personal use one. You could go ahead and download it. I will be sharing the link for this as well. So okay, so we have installed the Diva application here. We looked at the insecure logging, how things get insecure. I mean, the very critical data gets logged in an insecure manner. Let's say I'm going to give anything like uh, a credit card data here. So what I did here was basically use my tool called ADB Logcat. So Logcat is part of the ADB tool itself. So I'm going to run the ADB tool, and when I click on checkout, okay, so it kind of gave me the that particular detail in the log itself. Okay, so this was insecure logging. Okay, so in the next week, what we'll be doing is we'll be looking at it in a much more detailed way, because not just knowing about the security issue, but we should be knowing why does it happen and how does it happen. What mistake would the developer would have done that this kind of an issue is coming up. Okay, so that is one of the major things that we look at. But apart from that, we also looked at the hard coding issues. Hard coding issues being, the vendor key being present in the source code itself. So, okay, let me open that JDGUI again. If you guys remember, we went to the hard coding activity here. The vendor secret key was the secret key that we were supposed to put it here. Okay, and it gave us the access. Okay, so we also looked at things like insecure data storage. Uh, Let me open the file itself. Okay, so in the insecure data storage, the first one that we saw was in the shared preferences folder. Okay, I'm pretty sure you guys remember that all the application specific resources are stored in /data/data folder. And inside that, under the shared preferences folder, there was an XML file that had my username and password. The second one was in the database folder. Okay, there was a .db file which kind of stored my data in plain text. And third one was in a temporary file, which was uinfo temporary file. Fourth one again was a hidden file, if you remember, in the SD card area. Okay, so we used we had to basically find that particular file using the JDGUI, how it was saving and how we extracted it and all that. So that was insecure data storage. And let's go back. Okay, okay, fine, let me connect my charger here, that's okay. So another thing that we looked at was the input validation here, wherein we understood that there was a SQL, search that was being used at the backend. What we did was we tried to break this particular SQL query using some, couple of special characters like quotation and a logically true statement, such as either 1 equals to 1, or you could use something like A equals A. Okay, so when I do a search, it would give me, let's say if I do something like A equals B, I mean it would not show me anything because it is not logically true. A is not equals to B. Okay, so yeah, we were able to find kind of bypass this using a SQL injection. That was one part. Another part, in the input validation, we saw that it was allowing us to sort of access any URL that we gave. I click on view, it sort of shows me that particular URL. Maybe I'm having a bad internet and hence it's not showing at this point. That's fine. But what we were able to do is here was that we were able to sort of go ahead uh, and sort of get access to the internal files, either be it the shared preferences and all of that. So that's something that we did. Then today we looked at the access control issues, where we were able to sort of get access to these vendor API credentials by invoking an activity that was protected using an intent filter. Okay, one thing that we got to know is that never to protect using intent filters, right? So that was one thing. We'll be looking about the access control issues part 2 and part 3 in the next week, because these need couple of much more details before we get into them. Okay, so the hard coding issues, if you remember, we were able to kind of get it from the strings, that were part of a library file yesterday. Okay, so that was one of the ways how things were hard coded. If I may just kind of get you guys back to recalling it. Okay, so we saw that there was a class, a private class that was created, and when I opened this up, it was loading a particular library called divajni. And when I looked into those libraries, I found that one of the strings, had was the actual hard-coded password, right? So far we have been able to sort of look into all these things. I hope you guys, this has been like informative for you guys. We'll be looking into much more things at a much more broader level. The next week we're going to be focusing more on installation of these tools on Monday, and post that we'll be looking at from the developer's point of view, what are all the mistakes that the developers usually make, which end up making the application to be vulnerable. That is one part. Another thing is we are going to be using, we'll be getting completely into the application. We'll be looking at the application components. So what is an application component and all of that, you will get to know it much as we move ahead, like on Monday. So application components, mainly there are four different sort of application components, like how an application would have would have a communication with other applications in the mobile device, and how insecurely that could be done, and all of that. So we'll be using a tool called as Drozer for this, to sort of try and to see to bypass couple of things in these application components. Okay, so things like your activity is is an application component, your services is an application component. There is something called as broadcast receivers. Okay, so all these are different sort of application components. We'll be looking into all of them at a much detailed level, tomorrow, or on Monday when we start the session. Okay, so that's one thing. At After the next week, on in the third week, we'll be looking at much more advanced concepts, such as what is an SSL pinning and what is a certificate pinning, and how communications need to happen in a secure way between the application and the server, and a bunch of other advanced topics, like how do you sort of pen test a debuggable application, and all of them. Okay, so those are much more advanced concepts for which you need to sort of have some good amount of experience. So I'll be introducing a bunch of different set of applications for you guys to try. They're fairly pretty good applications that we have built. I'm pretty sure you will be able to sort of solve them easily. Let's see how it works out, with the applications. If you guys find it difficult to crack them, I'm anyways always there to sort of help you guys out. So for now, any other questions that you guys have, surely go ahead and I'll be able to answer them right now. Okay, so there is a question that says, how can we prevent these security flaws? What does the developer can do to avoid these security flaws? That's a really good question. So as I had mentioned, the next week is mainly, we'll be looking at these issues from a developer's point of view. Okay, like what mistakes that these are the developers are making. Something like, let's say if we take up insecure logging, why is these set of data being logged insecurely. Okay, there are different ways data could be logged. Okay, so there is a function called log function, like log.e log. There is logging for errors, there is logging for information, there is logging for different set of data. So we look at into those areas and see why they are happening and how they are happening. Okay, so once we know how these things are happening, and only then we'll be able to sort of be able to solve it and secure it in a much better way. So another question that I have here is insecure data storage part 4 in Diva. While I enter the login details, it throws up an error that throwing error occurred is that I didn't install Genymotion properly. No, not really. Genymotion has got nothing to do with your application not showing a certain thing properly or no. So Genymotion installation. So if you are able to sort of run the emulator properly and sort of see the applications inside them, then it means that you've installed your Genymotion properly. It has to be something else with respect to the application itself, the application diva itself. So when you said it is insecure data storage, the part 4 one, so there was no login details for the insecure data storage, if as far as I remember. The part fourth one, the fourth part was mainly for the data that was stored on the SD card. If that's the one that you are talking about, or as you said, it is login details. I think it may be something related to insecure. I mean, it's not the data storage for sure. It may be insecure, the input validation. Okay, so the name and the password. Okay, so it means that it is insecure data storage. So it has to be stored on the SD card itself. No, it never usually says that that you had some error or something. Maybe if the SD card option is not being used for your device, only then that error would come up. So yes, so what you could do is in the Genymotions option, you could go on and sort of enable the SD card options so that your mobile device could use it, and then that SD card option would come up. So only when that SD card option comes up, you'll be able to sort of save the data in the SD card. Yeah, that's the thing. Yeah, so the file error occurs with respect to insecure data storage, mainly because the SD card was not inserted from the Genymotion. So that's the only reason. All right, guys. So any other questions further? All right. Seems like we are done with questions for today, and so is with the session. So I hope you guys liked today's session. Okay, so the upcoming sessions are going to be much more interesting than what we had this week, because you are going to be getting your hands dirty with understanding, from the developer's point of view. I hope you guys, will be able to sort of understand it much better than what we have done this week. All right, then. Thanks a lot, guys. Have a great weekend ahead, and I see you. I'll be seeing you guys in the next session. Thanks a lot. Thank you very much.